Okay, welcome to another Ginger Mathematician video. So I'm going to go through some work on functions. So many of you have asked me for this exact kind of video, so I'm going to go through all of IGCSE functions, start some of the easier questions, working our way through to the AA style content. And if you like this content, then please do think about liking, which is the most important thing to do, and subscribing as well. Right, let's get started. So we've got question 13, unlucky for some, hopefully not for us. So we've got f of x is equal to 5 minus 2x, and we need to solve this equation. So I'm going to take this equation, I'm going to copy it out, and wherever I see an f of x, I'm going to replace it with 5 minus 2x. So I get 1 divided by 5 minus 2x is equal to 2. So essentially, actually, this is an equation solving problem. And when we do this, we have to use inverse operations. So I'm going to put a bracket here just to see what I'm doing. Now, this fraction is kind of annoying. So what's the opposite of dividing by 5 minus 2x? Well, I want to multiply by 5 minus 2x on both sides of the equation. Let's pop it up here. So if I multiply, it cancels this. This is the whole point. So we get 1 equals, and then we've got 2 lots of 5 minus 2x. And now we just need to rely on our general algebra skills here. We're going to multiply out the bracket using the hook. So I'm going to times this by this and this by this. So we get 2 times 5 is 10. 2 times minus 2x is equal to minus 4x. So we're getting closer to the solution. Actually, I'm going to put it over here just so we've got a bit more room. The first thing I'm going to do is add 4x on both sides. So I have the x on the left-hand side. So that gives me then 4x plus 1 is equal to 10. Well, these two things cancel. Almost there now. We've got a nice two-step equation. So we're going to minus 1 from both sides. The opposite of plus 1. This cancels, we're left with 4x is equal to 9, and then to get rid of the 4, what's the opposite of multiplying by 4? Well, we want to divide by 4 on both sides, finally getting to our answer of x is equal to 9 over 4. Now you could also write this as a decimal as 2.25. You can use your calculator for that, but you'll get both marks for either writing 9 over 4 or 2.25. Both are fine. Right, and let's look at part 2, where we need to find and simplify, and this is fun to say, f of x. So we want to work out f of x. Now this is what we call a composite function. And you're going to see a lot of these kind of questions in the questions we're going to do today. So the way we do this is as follows. Well, I'm going to write this out, and wherever I see an f of x, I'm going to replace it with 5 minus 2x. So I'm going to put in 5 minus 2x. And this is the stage that often causes pupils problems. So in order to work out this calculation, we're going to put the function into itself. Well, what does that actually mean? So I'm going to highlight the x here, and essentially wherever I see an x, I'm going to replace it with a 5 minus 2x, its own function. Now, what does that look like? Well, I'm going to copy out 5 minus 2x, and wherever I see an x, I'm going to put a 5 minus 2x. This takes a bit of getting used to, this idea of putting a function into itself, so to speak, but you'll see lots of questions like this. So by the end of the video, you should be used to doing this process. Now, once we've done that, now it's a case of expanding and simplifying. So again, we're going to use the hook to multiply out the bracket. So we're going to leave the 5 alone. Minus 2 times 5 is minus 10. And this is where to be careful with those negative numbers. So minus 2 times minus 2x is positive 4x. And if we simplify this down, well, we get 5 minus 10 is equal to negative 5 plus 4x. So that is going to be our final answer. Notice they want it to be simplified. That is a key word in the question. So if you don't put minus 5 plus 4x explicitly, you won't get all the marks. Now the next part is also a very, very standard question on IGCSE. So find the inverse of f. So if you see f to the power of minus 1, this is asking for the inverse. And these two words, inverse and composite, we're going to come back to again and again and again in this video. Now, how do we find the inverse of a function? We have a nice three-step process. So number one, we're going to make y equal to our function. So y equal to 5 minus 2x. It's always our first step. Our second step, we're going to flip the y's and x's. So what do I mean by this? Well, we're going to replace the y with an x. And we're going to replace the x with a y. So we get 5 minus 2y. And then at this step, number 3, which is the step that always takes the time, we are going to make y the subject. Okay, so how do we actually do this process? I'm just going to copy out the equation we did before. Now, in order to make y the subject, I want to put all the y's on one side and then all the x's on the other. So I'm going to do this in 2 steps. So first of all, what's the opposite of minus 2y? Well, I'm going to add 2y to both sides. That gives me then 2y plus x is equal to 5. Remember, these two things cancel. And now we're going to put the x on the other side. So what's the opposite of adding x? Well, that's going to be minusing x on both sides. This cancels. So we get 2y is equal to 5 minus x. Well, so close at this point. So we need to get the y on its own. What's the opposite of timesing by 2? Well, of course, that's going to be dividing by 2. This cancels, and so we get our answer of y is equal to 5 minus x all over 2, which is our answer. So that's going to be our answer, 5 minus x over 2. So the right-hand side of this equation, highlight it out like so, is the correct solution to this question. Again, we're going to get lots of practice on this as we go through the video. Now, part B is a sneaky question that they do like putting in on occasion. So g of x is a function with an inverse function, kind of opposite. So as soon as you see inverse, you'll be thinking opposite. Not quite the right word, but it just gives you an idea. G inverse of x, write down the value of g brackets g inverse of 3. Now, if you have its function and its inverse, what happens is they cancel. So if you ever see a g and a g inverse together, you can just cross them out. And what are we left with here? Well, this is equal to 3. And notice this is a 1-mark question, so it should be a very straightforward process to get to the answer. And alternatively, you could have put 3 into its inverse and then worked out g afterwards, but that takes far too long. Please remember this trick of if you have a g and a g inverse next to each other, they cancel out. Right, so you can have a look at the solutions. So this one here is not very clear in the mark scheme. This is the answer to part B. Right, let's move on to another very classical functions question for IGCSE. If you're liking the content as well, then please think about liking the video. Right, so this time we've got another composite function, but notice we have a number involved. So this makes our life a little bit easier. The first thing we're going to do is work out f of 7. So we're going to work out what's inside this bracket. So f of 7, so that means wherever we see an x in the f function, we're going to replace it with a 7. So we get 7 squared minus 7 minus 30. Again, this is a calculator question, but again, I'm going to work it out without. So 7 squared is 49, minus 7 minus 30. And then if we work that out, that's going to give us the answer of 12. Now this is the key point at this bit here. So we've worked out that this is equal to 12. So all we're going to do at this point is replace that with a 12. So we're going to work out h of 12. So h of 12, wherever I see an x in here, I'm going to change it to a 12. So we get 2 lots of 12 plus 7. So that's equal to 2 times 12 is 24. 24 plus 7 gives us our final answer here of 31. And notice the inverse function has come up again. So this here, as soon as you see that minus 1, you know it's going to be an inverse. And now we're going to use that three-step procedure that we saw on the previous question here. So question III. So hopefully you remember it at home, what we've literally just done. So number one, we're going to take our function and make it equal to y. So y is equal to 2x plus 7. Number two, we're going to flip over the y's and the x's. So we get x is equal to 2y plus 7. And remember that third step, give yourself 5 seconds to think about it. What was that step? That's it. We're going to make y the subject. So as soon as you see this inverse process, it's always the same calculation that we go through. So first of all, I'm going to flip it. So I have the y's on the left-hand side. And now I need to get y on its own. So we go through this two-step procedure. What's the opposite of adding 7? Well, we need to minus 7 from both sides. This cancels, so we're left with 2y is equal to x minus 7. And then we want to get the y on its own. So what's the opposite of timing by 2? Yep, we're going to divide by 2 on both sides of the equation. This cancelling, and we're left with our final answer of x minus 7 divided by 2. Remember, this y equals whatever's on the right-hand side, right at the end, is going to be our answer. So this x minus 7 divided by 2, like so. And if you're aiming for, say, a C grade or even a B grade, you need to make sure you're getting these first two questions correct almost 100% of the time. So you've got that in the bag. So when we go into harder questions, then you've already got that grade secure on these questions. Now the next one is g of h of x. This is what we call a composite function. So keep writing these keywords down, and notice it says simplest factorized form, which we'll come to right at the end of this question. Now first of all, what is h of x? Well, it's equal to 2x plus 7. So I'm going to copy out this, and wherever I see an h of x, I'm going to put a 2x plus 7. Now once I know that, I'm going to look now at my g function. So this is my g function here. And wherever I see an x in my g function, I'm going to replace it with a 2x plus 7. So it's a bit of a trickier question compared to what we did last time. So if I copy this out, I get 2x plus 7 all squared minus 36. And so now we've got a bit of algebra to do to expand everything else and simplify. So remember, if you've got a bracket squared, so 2x plus 7 all squared, this is the same as saying 2x plus 7 multiplied by itself. And as soon as you've got double brackets, you know what's coming. We're going to use FOIL. So remember, FOIL is first, outside, inside, last. So you have to make sure you follow this very logical procedure. So let's do this. So 2x times 2x, that's equal to 4x squared. 2x times 7 is equal to 14x. 2x times 7 in the middle is equal to 14x as well. And then finally 7 times 7, that's equal to 49. And before I copy this across to down here, let's just collect the like terms. So we have 4x squared, we leave that alone. 14x plus 14x is 28x, and then we have the 49 as well. So I'm now going to copy that across to our calculation. So we get 4x squared plus 28x plus 49, and don't forget the minus 36. So let's just simplify this down. So we have 4x squared plus 28x, and 49 minus 36 is plus 13. Now many students out there think they've got the final answer. They start celebrating, but remember what I underlined earlier. It's simplest factorized form. And as soon as you see factorized, that's a mathematical word to put into brackets. So we need to think how we're going to put this into brackets. Well, because we've got a quadratic here with all the three terms, it's going to go into double brackets. And now we have to think about what's going to go inside them. Well, 4x squared, well, that can be 2x times 2x. You could also do 4x times x as well, but we'll start with this one first and see what we can work out. So remember, to work out these numbers here, we need two numbers that multiply to give us 13. Now there's not many options here because 13 is a prime number. So we have either 1 and 13. We could also have minus 1 and minus 13, but notice this is a positive number, so it can't be minus 1 and minus 13. So that leaves us with only one option here, which is 1 and 13. So let's pop that in. And what I'd always do in the exam is check that we do get the middle term here by checking the cross terms. Now what do I mean by the cross terms? Well, I mean when we multiply the outside here and the inside, because that gives us our x term in the middle. So let's just double check this. Well, 13 times 2x is equal to 26x. 1 times 2x is equal to 2x. 26x plus 2x is equal to 28x, which is exactly what I want in the middle. So that's going to be our third mark, making sure you can put this into double brackets. So that's pretty tricky to notice that, first of all, you need to do that process, and then secondly, that this difficult factorization is actually possible here. Okay, let's move on. So now we're going to have to simplify f of x divided by g of x. So let's just remind ourselves what those functions are. So we have x squared minus x minus 30 as our f function. And then our g function down below is x squared minus 36. So this is turning essentially into an algebra question, even though this is under functions. And what we want to do is simplify. So the first thing we see here is that we have quadratics in both. So we want to try and put them into brackets. And then we hope that something will simplify as we go through. Now if we look at the bottom one here, x squared minus 36, this is a special form of quadratic known as difference of two squares, or dots as I like to call it as well. And what this means is that both of these are square numbers. X squared is a square number and 36 is equal to 6 squared. And this has a very special factorization that you need to learn for the IGCSE course. And what this means is we can put this into brackets of x minus 6, x plus 6. Now if you don't believe that, you can always go through FOIL and check the expansion. The key thing here is that the plus 6x here and the minus 6x cancel, and this is why there is no middle term here. This is a factorization you need to recognize, particularly on paper 2 questions. This is actually a paper 4 question, but it's useful to do. Now you can be kind of sneaky with these questions because you know if it's anything going to simplify, you know there needs to be an x minus 6 or an x plus 6 up here, so we can cancel later on. Now we know there's an x at the start here, and what we need to do is factorize the top. So we need two numbers that multiply to give us minus 30, but add to give us minus 1. So that's what's going through my head here. Multiply to give me minus 30, but add to give me minus 1. So what I do here is write down all the number pairs that multiply to give me minus 30. Well, obviously got minus 1 and 30. We have minus 2 and 15. We can move the minuses around. So 1 and minus 30, 2 and minus 15, 3 and minus 10, and minus 10 and 3. And you're thinking, God, that's a lot of combinations here. Minus 6 and 5, 6 and minus 5 as well. But remember that second rule that I talked about here. So you also need to add to give me minus 1. If I look at these combination here, the only one that works here is this one here. Remember, minus 6 plus 5 gives me the negative 1. So even though there's lots of combinations, using that second rule that we're allowed to, because there's no number in front of the x squared, limits down those options. So we put in x minus 6 and x plus 5. And yes, we get exactly what we wanted here. We get the same bracket above and below. And if that happens, then we are allowed to cancel. So we can just cancel these through. And then we get our final answer for 4 marks of x plus 5 over x plus 6. So we can write that in like so. Okay, 4 marks, there's a lot of working here to do, recognising dots, factorising the top, realising you can cancel, and then getting to our final answer. But if you're looking for those higher grades, those AA star grades, these are questions you need to be getting all those 4 marks on. Right, so you can check the solutions that I've gone through here. A little bit sneaky at the end. They did it a slightly different way with the factorisation process, with the splitting the term, but again, as long as you have a method for it, that's absolutely fine. Right, and on to another functions question. So here we go, we've got 3 different functions this time, and we want to work out g of minus 3. This is usually the most basic skill on IGCSE, and all this means is wherever we see a minus 3 in the x in the g function, we're going to replace that x with a minus 3. So I'm going to copy out our g function, and wherever I see an x, I'm going to put a minus 3. And then we just use our normal BIDMAS to work this out. Remember, multiplying comes before subtraction. So minus 2 times minus 3 is equal to positive 6. Just be careful with those negative numbers. And then 5 plus 6 is equal to 11. And then we're on to this next question. Again, another composite function. Again, these skills come up again and again and again. So the first thing we're going to do is work out what's inside the bracket. So h of 2. So wherever I see x here, I'm going to put a 2. So we get 2 squared minus 3. Hopefully getting the hang of it at home. So we get 2 squared is equal to 4. 4 minus 3 is 1. And then we take that answer. So let me just highlight that. We take this answer and we replace the whole h of 2 with 1. So what we actually need to work out now is now f of 1. So we put 1 into this function. So wherever I see an x here, I'm going to put a 1. 4 lots of 1 plus 2. 1 times 4 is 4. 4 plus 2 is equal to our answer here of 6. Again, these questions A and B, you need to make sure you're getting them. C is also in that category. And this is the other kind of question they could ask you. So find x when f of x, the whole function, is equal to minus 10. So again, I do the similar process to what I did before. So wherever I see a f of x, I'm going to put a 4x plus 2. So 4x plus 2 is equal to minus 10. And this now is just an equation that we need to solve and get x on its own. So what's the opposite of adding 2? Well, we're going to subtract 2 from both sides. This cancels, and we're left with 4x. Minus 10 minus 2 is equal to minus 12. Careful with those negative numbers. And then we want the x on its own. So what's the opposite of timesing by 4? Well, we're going to divide by 4 on both sides. These cancel. We are left with x. And then minus 12 divided by 4. Well, that's going to be equal to minus 3. Again, you can use your calculator on these questions. These are paper 4 questions. X is equal to minus 3. And now we're going to get a few little twists on the questions that we've looked at so far. So next we need to write down the range of h of x, not a word we've encountered so far. And remember, the word range in functions in normal English is what y can be. So what is y allowed to be? And one of the best ways of doing this is by using a sketch. Now, h of x is equal to x squared minus 3. Now, what does that function look like? Well, of course, we can always use a calculator to help us visualize this. So I'm going to do that in case you don't know what this looks like. Let's use the calculator, since this is a calculator paper, and see what it looks like. Okay, so you can use calculator by going to the graph function. And all I'm going to do is type in x squared minus 3. And notice we get a sketch here where it goes through this point here at negative 3 and we have this parabola shape. So if you didn't know that already, that's absolutely fine. You can use your calculator to help you visualize what it looks like. So I'm going to do a quick sketch here just of the function that we just saw. So I'm going to draw in parabola like this, where this crosses at negative 3 using this number here. And what it wants you to do is work out the range, so what y can be. The easiest way of doing this is the so-called horizontal line test. Okay, not a vertical line test, but a horizontal line test. So if I draw a horizontal line here, do I hit the graph? Well, no. If I draw a line here, do I hit the graph? No. If I draw a line just here, I just touch the graph, which is absolutely fine, at -3. If I draw another horizontal line, I touch the graph twice. That's amazing. If I draw the line going across here, I touch the graph twice. That's amazing. And you can probably see if I just keep going up and up and up, I will always touch the graph. So what we need to work out is, okay, when do I actually touch the graph? And I touch the graph at -3 and everything bigger than -3. Now, how do I write that in the right notation? Well, I write down the function h of x is greater than or equal to, because it's allowed to touch -3 as well, -3. So whenever they ask you a range or domain question, this is what they're asking for. For the range, what can y be? Draw horizontal lines and see when you touch it. For domain, what x can be, you draw vertical lines and then you see what you can touch there. Okay, hopefully we'll see a question later on where we talk about the domain as well. And now we go on to question E, which again is a question you need to be getting right because it's that -1 there again. That means we're going to go for an inverse procedure. Now f of x was equal to 4x plus 2, just as a reminder. And we're going to go through that 3-step procedure. Number 1, we're going to make this equal to y. So y equals 4x plus 2. Number 2, we're going to flip over those y's and x's. So x is equal to 4y plus 2. And then number 3, hopefully this is a really embedded procedure in your mind, is to make y the subject. So y equals something. So let's go through that procedure. So first of all, we're going to flip over the equation. So 4y plus 2 is equal to x. Then we're going to want to get the y on its own. So what's the opposite of adding 2? Well, minusing 2 on both sides. This cancels. We're left with 4y is equal to x minus 2. And you probably see where we're going here. So we've got a times by 4. What's the opposite of that? Well, divide by 4 on both sides. This cancels. We're left with y equals x minus 2 over 4. And remember, the right-hand side of the equation is that inverse function we're looking for. So we're just going to write in nice and neatly x minus 2 over 4, and then we've got our answer there. So if you're looking for that sort of B grade, then certainly make sure you can do from questions A to E. If you're looking for the harder grades, so we haven't looked at questions like this, more unseen material or unfamiliar material, this is definitely the A star element of our question. And what they like to do here is combine a couple of topics together. Here we're going to do a little bit of work with transformations. Now we're told k of x is equal to 10 minus 4x. And we need to describe fully the single transformation that maps the graph of g of x. So let's remind ourselves what g of x is. So g of x is equal to 5 minus 2x onto the graph of k of x. And the first thing I do when I'm looking at this is, how are these similar? So how are 5 minus 2x and 10 minus 4x similar? And the first thing that comes to mind here is actually, I can factorize this into a single bracket. I can take a factor of 2 out. So if I take 2 out, what do I multiply 2 by to give us 10? Well, 5. And what do I multiply 2 by to give us minus 4x? Well, that's minus 2x. And notice, well, actually, there's a 5 minus 2x here, and our g function is also equal to 5 minus 2x. So I can just replace that entire bracket, get the highlighter out here, this entire bracket with just g of x. So I get 2 lots of g of x. So k of x is just 2 lots of g of x. And this is where we go into transformations of functions. So if I write 2g of x, what transformation does this signify? Well, whenever you're multiplying a number by a function, you know that means it's some kind of stretch involved. And if you're not sure where this knowledge has come from, then just check out Transformations of Functions IGCSE on YouTube. You'll find a video that goes exactly through it. Now, because the 2 is outside the function, we have a stretch in the y direction, so vertical direction. So I'll put vertical in brackets. And because the 2 is outside the function, the stretch factor here, will be a factor of 2. So now we need to write this in the right way that gives us all 3 of these marks. So first of all, we're going to write there's a stretch involved. So that's for 1 mark. We have a stretch factor. I'm going to write out in full here, stretch factor of 2. And now we need to say where it's stretching from. Well, whenever we work with transformations of functions, it always stretches from the axes. So imagine we're stretching vertically, it's always going to be stretching from the x-axis. So what we write here is x-axis, and this is the smart word that we need to write in here, invariance. So that's just a mathematical word for where we're stretching from. So, yeah, so where we stretch from. And hopefully you're familiar with that word invariance from the work you've done on transformations. Generally speaking, when you use tracing paper to do reflections and rotations, you need to know that word. And to pick up all 3 marks, you need to be very, very clear that the x-axis is going to be invariant. Right, and now on to another little twist on transformations of functions with part G. So the graph of y equals h of x, which remember h of x is equal to x squared minus 3, is translated by the vector 2, 0. And we need to work out the equation of the graph of the image. So if I take the vector 2, 0, remember that just means moving 2 to the right. Now, how do I actually write that in vector notation? This is something really to remember here. It works the opposite of what you expect because we're moving horizontally. So what they're looking for here is h of x minus 2. And that's a really, really important fact to realize. 2 to the right is actually minus 2, not plus 2. So what we're actually looking for here is we're actually looking for h of x minus 2. So I take my h function, wherever I see, get the highlighter out, an x, I'm going to replace it with x minus 2. If I do that, I'm going to get x minus 2 all squared minus 3. If we expand that bracket, I'm going to do this quickly just to show you what happens here. So x squared minus 4x plus 4 minus 3. And then if we collect the like terms, we get x squared minus 4x. 4 minus 3, of course, is equal to positive 1. And we get our answer there. The most difficult part conceptually is this part I've just done over here separately. So if you're moving something by a vector or translating by a vector, then to put it into function notation, we need to put h brackets x minus 2. And this is why this is an AA star question, because we're combining it with another difficult part of the course that we've already seen. Okay, and you can see the mark scheme. Notice for part F, I approached it this way. I think this is the most straightforward, but it can be done with a reflection and rotation as well. Right, on to another function question. So we're on to question 8. So the first part, very standard. We need to work out f of minus 3. So wherever we see an x, we're going to replace it in our f function with minus 3. Now this is where we have to be careful with brackets, because we need to put a bracket around the minus 3, because we're squaring that, plus 1. This is where you can easily lose a mark. So remember, minus 3 all squared is minus 3 times minus 3. That's equal to positive 9, and 9 plus 1 gives us our answer of 10. And now we've got a very typical composite function. Again, hopefully getting the hang of this at home, because we do this regularly. So we've got h of 1 first of all. So h of 1, let's work that out. So wherever we see an x here, we're going to replace it with 1. So we get 1 over 1 plus 1. That's equal to 1 over 2, which I'm just going to write as a decimal, 0.5. And now I can replace the entire h of 1 with 0.5. So now we're going to work out g of 0.5. And that gives us 3 plus 2 lots of 0.5. If you wanted to, you could use a calculator at this point. This will just give us, well, 2 times 0.5 is just 1. So 3 plus 1 is equal to 4. And now we're moving into that sort of B category here, BA category, where we want to simplify the following expression. So first of all, let's work out this f of g of x. Well, g of x is equal to 3 plus 2x. So we'll do f of 3 plus 2x. Now we actually know what f of x is already. We already know this is x squared plus 1. So let's just replace this with x squared plus 1. And now we need to work out this composite function. So let's look at our f function. Wherever we see an x, you know it, we're going to replace that x with the 3 plus 2x. So I'm going to replace that with, in brackets, 3 plus 2x. So that gives us 3 plus 2x all squared plus 1, so don't forget the plus 1 here, and then we've got a plus x squared and a plus 1. So now we need to multiply out this double bracket. Remember, squaring is the same as multiplying by itself. So again, we're going to use some FOIL here. So 3 times 3, that's equal to 9. 3 times 2x is equal to 6x. Notice I'm speeding up a bit as we're going through these questions again. 3 plus 2x is equal to 6x. And 2x times 2x is equal to 4x squared. If we collect up those like terms, then we get the answer of 9 plus 12x plus 4x squared. Let's pop that back over here. So we get 9 plus 12x plus 4x squared plus 1 plus x squared plus 1. And now if we collect up all the like terms, well, 4x squared plus x squared is 5x squared. And then 12x, just 12x. We have no other x's to collect. And then we've got some numbers. So we've got 9 plus 1 plus 1. That's equal to 11. And notice this time they do not ask us to try and simplify in any way like the previous question. So just make sure you're reading the question, and if it is factorizable, if that's a word, then they'll obviously say that to you. If they just want to work out the answer, then they'll tell you that as well. And you probably know an inverse function is coming up, and guess what? There is an inverse function. Notice this one is out of 3 marks, however, so it's probably going to be a bit more complicated. So our h of x function is equal to 1 over x plus 1. So again, we still do this 3-step procedure. So number 1, we're going to make that equal to y. Step 2, we're going to switch over the x's and y's. So x is equal to 1 over y plus 1. And you know it at home, we are going to make y the subject. Now this time I'm not going to flip the equation, and this will become clear as we go through the working. So x is equal to 1 over y plus 1. Generally, fractions we do not like when we're solving equations, so let's get rid of that as quickly as possible. So what's the opposite of dividing by y plus 1? Well, we want to multiply by y plus 1 on both sides of the equation. That gives us x lots of y plus 1. Now this cancels, which is very helpful, and we're just left with the numerator here, which is 1. Then we're going to multiply out the bracket, so a little bit more work here. So x times y is just xy, and x times 1 is just x. And then we want to make y the subject, so we've got a couple more steps to go here. Let's get rid of this plus x, so minus x on both sides. So it gets this cancelling, so we get xy is equal to 1 minus x, and we're almost there now. So what's the opposite of timesing by x? Well, we want to divide by x on both sides. This then gives us y equals 1 minus x over x, which is our final answer. This could be written differently as 1 over x minus 1, but I'm happy with the way that I've written it here. So let's just... Oh, that was the rubber. No, don't get the rubber there. 1 minus x, there we are. So let me get the highlighter out. There we are, there's a highlighter. And you'll see there's the answer which we want for all 3 marks. And now we've got some interesting solving questions to do here. So we've got g of x is equal to 1. So g of x is equal, just remind ourselves, 3 plus 2x. Exactly. And we want to make it equal to 1. So I'm just going to change that g of x to what we know, which is 3 plus 2x is equal to 1. And now we want to make x the subject. So the opposite of adding 3, that's minusing 3 from both sides. This cancels. We're left with then 2x. 1 minus 3 is equal to minus 2. Again, use your calculators if you don't like your negative numbers. And then the opposite of timesing by 2 is dividing by 2 on both sides. This cancels and we're left with x is equal to negative 1. So we can just pop that answer over here. So negative 1. And now we've got this interesting equation here. So we want to work out the inverse of g is equal to 1 instead. It's a 1-mark question. So I'm interested to see why it would be so straightforward, but I'm just going to work out the inverse function very quickly. So 3 plus 2x. I think this is the kind of standard way of doing it, but it's probably not the quickest. So we get 3 plus 2x. We swap this over. I feel like I could do this a bit quicker. This then leads to y equals x minus 3 over 2. And then that's going to be our inverse function, so I replace it here. I could do this a lot quicker. Times by 2 on both sides, x minus 3 is equal to 2. So x is equal to 5. So this will be equal to 5 here. So once you get really quick at working out these inverse functions, that's probably the quickest way to go to actually do these kinds of questions. Okay, so you can check the answers that you see in front of you. And let's have a look at one more question. So on to question 11, and now we've got 10 to the power of x. So you know there's going to be some logs involved a bit later on, so that's going to be fun. So first of all, we need to work out the value of g of 3. We've seen lots of questions like this now. So wherever we see an x in the g function, we're going to put a 3. So you get g of 3 is equal to 2 lots of 3 minus 1. 2 times 3 is 6. 6 minus 1 is equal to 5. Nice, so we can just put 5 there. And now this is a slightly different kind of question. So we have to find the range of f of x for the domain minus 1, 0, 1, and 2. So remember the domain is what x can be. That's what the domain means. And it wants us to work out the range, so what y can be. This is actually more straightforward than it looks. So all we need to do is substitute these numbers into our f function and work them out. So we need to work out f of minus 1, f of 0, so just using these numbers here, f of 1 and f of 2. And just pop these in. So f of minus 1, so I'm going to replace the x with minus 1. That gives us 10 to the power of minus 1, which you can use a calculator for, is equal to 0.1. And then 10 to the power of 0 is equal to 1. 10 to the power of 1 is equal to 10. And then 10 squared is equal to 100. And these 4 answers that we just worked out here make up our range of the function for the 4 specific numbers that we're given. So we just write in 0.1, 1, 10, and 100. On to part C. So again, very standard kind of question here. Find x when g of x is equal to 12. Now our g of x function was 2x minus 1. So just a reminder of what the function was. So I'm just going to replace g of x with 2x minus 1. That gives us 2x minus 1 is equal to 12. And now we just want to make x the subject. So the opposite of minus 1, that's equal to plus 1 on both sides. That cancels. We're left with 2x is equal to 13. And then the opposite of timesing by 2 is divide by 2 on both sides. And that gives us x is equal to 13 over 2, which is perfectly fine as an answer. Or you can work this out by decimals. by decimals, and then that gives us 6.5 as our answer. And notice this question is very similar to a question we saw before. So the graph of g of x is translated by the vector 2, 3 onto the graph of h of x. And now we need to work out what h of x is. So g of x is equal to 2x minus 1. And remember, in vector notation, this just means 2 to the right and 3 up. So to work out h of x, we just need to make sure this goes 2 to the right. So in the bracket, we need to put a minus 2. But it works the opposite of what you expect in the bracket. But outside the bracket, it works the way you do expect. So we need to put a plus 3 to indicate it goes 3 upwards. So now we've turned this into essentially a composite function kind of question. So all we need to do is take our g of x function. Wherever we see an x, we're going to replace it with an x minus 2. So we get 2 open brackets x minus 2 minus 1 plus 3. And now we just need to expand the bracket and simplify using the hook. So we get 2x minus 4 minus 1 plus 3. If we simplify that down, that then just gives us 2x minus 2 for our final answer. This is the tricky part, realizing that 2 right, 3 up in function notation essentially means gx minus 2. So this part means the 2 right, opposite of what you expect, whereas the plus 3, this is the 3 up. It does work in the way that you expect. And to get the higher marks on the function questions, you need to be able to tie in functions into some difficult algebra that we've seen already in this video, or using transformations of functions. Okay, and on to part E. So now we need to work out an inverse, the classic. So let's go back. Aha! So this is where the logs come in. So f of x is equal to 10 to the power of x. And we do it in the same way, but this is a little bit trickier. So first of all, we make y equal to 10 to the power of x. Number 2, we switch them over. So we get x is equal to 10 to the power of y. And now we need to make y the subject. And yeah, this is not so straightforward to do on the surface. First of all, I'm going to flip it over this time. So 10 to the power of y is equal to x. And now I need to think what the reverse process is of raising to a power. And that is taking the log, base 10, of both sides, which is not the most obvious step to make. Let me see if I can make it clear as we go through the working. I will put base 10 just so you can see what's going on. So we get log 10 to the power of y is equal to log x to the base 10. Now I'm just going to simplify the left hand side over here. So using some of the log laws on our course. Now remember, with log laws you can take the y and bring it to the back. I call it log law number 3. So we get y log 10 base 10. And if the base is the same as the actual number of the log, this just simplifies to 1. So these cancel, and then we're equal to just y. So this then leads us to the answer of y is equal to log x base 10. Now because of this course, you're not expected to work with different bases, generally speaking, so you can just leave it as log x, that's absolutely fine. But if you put base 10 as well, that's also okay too. Okay, and on to our last question, which is where they start tying in some trigonometry into this as well. So you need to be prepared for this for these AA star questions. And first of all, we've got tan of g of x is equal to 1 between 0 and 180 is our domain, to what x can be. And we need to find the two values of x. They've been very helpful. They've told us there are two answers in this question. Now g of x is equal to 2x minus 1. So tan, wherever I see a g of x, I'm going to put a 2x minus 1. And this is equal to 1. So essentially they want us to work out a trigonometric equation, which is quite rare on this particular course, but it can come up. Now the way to look at this is we can actually work out one of the answers here by working out inverse tan of both sides. Notice I said one of the answers. So if we do tan inverse on both sides, this cancels. We're left with 2x minus 1. is equal to tan inverse of 1. Unfortunately, this is not an exact value, so this is where we actually need to use the calculator. So make sure this is in degrees at the top. So we're going to work out tan inverse of 1. That gives us 45 degrees. Now we could have done that using exact values. Towards the end of the video, I'm going, okay, should have known that, but okay, that's fine. This is equal to 45. However, there is another answer, and you can see this by drawing a quick sketch of the tan graph. So a tan graph looks like this, and essentially it repeats every 180 degrees. So we've worked out one of the answers here. So we've worked out this answer, 45, but notice it also crosses the graph here as well, because there are two answers to the question, we're told. And it repeats every 180 degrees, so this will be 225. So whenever you've got trig equations, there are two answers. Now, why do we need both? Well, we need to make x the subject here. So we approach this in the same way that we normally do. So we add 1 to both sides. That gives us then 2x is equal to 46 degrees and 226 degrees. Then we divide both sides by 2. Make sure we do the same to both sides, and that then gives us x is equal to 23 degrees and 113 degrees. These are the only two answers that lie within the domain. If we added on an extra 180 to get the third answer, that would not lie in the domain afterwards. So we get 23 degrees and 113 degrees. Now, before I finish this question, there is an alternative to actually working this out, and that's by taking this answer right at the start. So, because this is a GDC course, I do want to show you another way of working out the answer. So, what we do is we go to our graph function instead. And something I really encourage you to do, particularly if you're going on to IB, is first of all we type in tan 2x minus 1. That's going to give us a tan graph, and at the moment it looks kind of weird, but we need to change that domain that we talked about before. So we change x between 0, I'm going to put 200 just so you can see what's going on. This will then give us that tan graph that I drew a quick sketch of. Now we put in the right hand side of the equation. So notice the right hand side of the equation was 1. So all we do is press the tab button. Oh, it's doing something very, very weird. All I want to do is type in 1. There we are. There we are. And notice that it crosses the graph twice. So all we need to do at this point is just go to Menu, Intersection. And if we work out the two intersection points here, you'll notice they're exactly the same answers as what we worked out in the question. And I do encourage you, particularly if you're doing IB next year, to actually use your graphical calculator, because it can really, really save you time. So notice this is another valid way of working out the answer of 23 and 113. Okay, so you can have a look through the solutions. Interesting, I think on for question F, they generally went with the algebraic approach, which is what I did at the start as well. And if you want to catch up on all things probability, then do click on the video you see in front of you, because I do a very, very similar process to what I did here, but going through all those really important probability questions for you.